All right. Hello, everyone, and welcome to our first lecture in our lecture series for Math 141. For this first part of the lecture series, we are going to be talking about the basic mathematics that underpins various forms of elections. So in this video, we'll talk about something called the plurality method and then the Borda count method, and we'll continue our study as we go forward in future videos. So what I did to start this discussion is I asked my class, so we have about 100 people in class, and I asked them, amongst other things, to rank the 3 ice cream flavors listed here in order of preference, right? So I asked them to rank which ones they prefer, sort of in a linear order, first place, second place, third place, between the ice cream vanilla right here, between the ice cream mint chocolate chip, and then between the ice cream salted caramel. So in practice, what this means that I got a bunch of, an Excel spreadsheet with a bunch of rows on it. And I had to figure out, how to total all the ballots. But when there's 3 ice creams, it turns out that there's 6 possible combinations. And this group of tables right here sort of summarize all of the possible results and how many people voted for each. So for example, in this one right here, we see that we had 18 votes where vanilla was first, mint chocolate chip was second, and salted caramel was third. And similarly, we can read through the rest. So 20 people thought that the order should be vanilla, salted caramel, mint chocolate chip. 24 people thought mint chocolate chip, vanilla, salted caramel. 18 people thought mint chocolate chip, caramel, vanilla. And then we had 9 and 11 people. So we have salted caramel, chocolate chip, and vanilla, and then salted caramel, vanilla, and mint chocolate chip. So those 2 orders got 9 and 11 votes respectively. So what I would like to do, at least to start these first 2 videos, is decide which ice cream is the best, which one should we elect as the best ice cream using various different forms of voting. And so before we dive into details, I want to ask, so talk to your neighbor, in that case, think to yourself about different areas where we encounter elections of some form. So don't be afraid to be creative. So why don't you take 30 seconds, pause this video, and then we'll just kind of go over some things that I came up with. All right, so I hope that you all paused the video there, or you just waited a little bit just to see me reveal some elections. So of course, we have elections when we discuss things like, presidential, mayor, governor, Senate elections. But other things that feature elections are Emmys, when we try to decide, what is the best movie? Who is the best actress? We have competition TV shows, maybe like Dancing with the Stars. That's going to use some type of election format. And, even things like student council and student government. So every student government at most universities, they all kind of have their own way of doing elections. So sports, for example, as well, the Heisman Trophy, that's decided on an election as well. We'll actually talk about that method today, but we're sort of always surrounded by elections in various forms, whether we're, aware of it immediately or not. We'll certainly be aware after going through all of these lectures. All right, so let's scroll down and talk about some basic vocabulary that we need today. So we just need a common vocabulary when we're discussing elections, but fortunately, most of it is fairly intuitive. The first piece of common vocabulary we need is that, so every election, it includes candidates. So candidates in an election are just the things that are being voted on. They can be people, like in a mayor election, or they can be different ice creams, like we just voted, like we just saw the results of that vote above as well. Then, of course, every election has voters. So voters are going to be people who vote. They're going to be people who fill out ballots. So we are most often going to be interested in what's the total number of voters in our elections. All right, so we have candidates, we have voters. Once we know how many voters we have, we can determine a very important number called the majority threshold. So this is a bit of a mouthful, but the majority threshold is the smallest number greater than 1/2 of the total voters. So we should be familiar with majority thresholds. If we have a group of 6 friends, we want to decide what pizza to order. We know that the majority is 4. So if 4 people agree, they sort of overrule the rest of the group. That's maybe one form of election that we do in our day-to-day life. So basically what this means is that, for example, 101 voters, that's going to mean that the majority is 51. All I did there was say, what's 101 divided by 2? And I ended up with 50.5. And so I round up. So I get 51 as the majority. That is the number greater. That's the smallest number greater than 1/2 the total voters. What if we had 102 voters? Well, 102 divided by 2 is equal to 51. Now, the 51 is not the majority because 51 is exactly half, right? So we could have an election between 102 people, and then 51 people choose one thing and 51 choose the other. So that's a tie. So a majority needs to be sort of like at least one bigger than a tie. So in that case, well, 102 divided by 2, that was 51, like we said. Since 102 is an even number, we add 1 so that the majority threshold becomes 52. So we'll see that this is an important quantity in many elections. All right, next up, every election does include ballots at some point. So ballots are the means by which we vote. And there's actually a lot of different examples of ballots. So the one that we might encounter most often in politics are single choice ballots. So in a single choice ballots, voters choose one of many candidates, their most preferred candidate. So something where we see this is in a typical presidential election in the United States, right? You vote for your most preferred candidate, and then you don't consider any of your other preferences. In these videos and in this class, we'll actually be considering something with a little bit more details, and that's the notion of a preference ballot. So in a preference ballot, what the voters are going to do is they'll have a list of candidates, and they're going to give up their preference to many or all of the candidates, depending on the format of the election. So we will study full preference ballots where voters rank all candidates, right? So you say, this is my first preferred candidate, my second, my third most preferred, and my fourth most preferred. So voters have to, you list your full preferences. Now, in practice, things like partial preferences exist. Maybe we have 10 candidates and you're asked to rank your top 3. So that type of election would feature partial preference ballots. The nice thing for the purposes of this course about full preference ballots is they tell us the complete voter preference between any 2 candidates, and all information about what a voter feels about all the candidates can be extracted from a full preference ballot. For example, if we removed the first place candidate, we would know that their next most preferred candidate is the second place candidate. That's the one they prefer to everyone else if we remove the first one. So it sort of allows us to compare any pair of candidates as well. And we'll see that that's something that we're going to want to do. So that's the idea of a preference ballot where we just list our preferences in order. And then we have this idea right here of a preference schedule. So a preference schedule is just a compact summary of all the preference ballots. It tells us everything we need to know about election. I'll tell you how to convert an election result into a preference table just below. All right. Then, of course, the last thing about elections is that they have outcomes. So that's the results of the election only. So there's many ways to decide the outcomes of an election. One thing that we're very accustomed to in politics is winner only. So only first place matters. So in the US presidential election, we only care about listing the winner of the election. Of course, sometimes we'll get a partial ranking of the candidates. In some elections, it matters, who got second place, who got third place. So in a partial ranking, only a few of the top places matter. So for example, maybe student council elections have a feature that, well, there's 5 candidates, but depending on what election you do, the first place is going to be president and the second place will be vice president. Maybe the third place is treasurer. So maybe we've encountered partial rankings before where, we actually do care about who second and third place are because they get a role. So previously in the United States, second place became vice president. That's a very important plot point in the musical Hamilton. All right. And then something that we'll often concern ourselves with is the full or complete ranking of all of the candidates. That's a complete list of the rankings. So if we had 5 candidates, we'd order them in who got first place, second place, third place, fourth place, fifth place. So that gives a complete description of all the results of an election. Finally, what we require is a voting method, and we will study 4 different voting methods in this course, 2 in this video. All right, so that's some of the vocabulary that we'll use. I'll stay here for a second. You can pause the video, take a peek at some of these things. Just make sure that we're comfortable with the language. All right, so let's talk about these preference schedules. That's something that I just mentioned earlier before. So a preference schedule is just a table that summarizes the preference ballots of all the voters in an election. So let's just talk about preference schedules first. So what I want to do just as an activity, and we'll just go through the first 3 columns, I'll give you some time to think about it, is we want to fill in the preference schedule for the ice cream election. Now we're going to want to keep all of our data compact. So I'm going to use the letter V for vanilla. I'm going to use the letter M for mint chocolate chip, And then I'm going to use the letter C for salted caramel, C for caramel. Maybe I should have called it S. But basically what we do to find the preference schedule is we just want to take the number of voters and then which preferences that those voters have. And what I'd like to do is I'd like to have the most popular sort of set of preference ballots. I'd like that to be in the first column, so the one with the most votes, and then we'll just go in descending order. So how do we fill out a preference schedule for the ice cream election? Well, what I would do is I would look up and I would want to figure out, well, what was the most popular ballot? So if I scroll up, I think the most popular ballot here was the one with 24 votes, and that was mint chocolate chip, vanilla, and salted caramel. So what I would do to fill out the preference schedule is I would go down and I would do this. I would list, there were 24 people who had first choice mint chocolate chip, second choice vanilla, and third choice salted caramel. And then what I want to do is, well, let's just go down to the second column now. So I go to the second column. All right, what was the second most popular vote? That's the one with 20 votes, and that was vanilla, salted caramel, and mint chocolate chip. So what I would do is in this spot for the number of voters, we have 20 people, and they voted as first choice vanilla, second choice salted caramel, third choice mint chocolate chip. All right, and then we can continue to fill everything out. So I won't keep scrolling back and forth, but what you would see is that the preference schedule would be filled out just like so. We had 18 people who preferred vanilla and then mint and then salted caramel, and then 18 people who preferred mint, then caramel, and then vanilla. If there's ever a tie, you can just list them in whatever order you want. It's just easier if we keep everything in a descending order. So as we see, the preference schedule is just a nice little compact table. It tells us the first choice, the second choice, the third choice, and it tells us how many people had that particular set of preferences. All right. The next concept that's helpful for tabulating, winners and losers of various forms of election is something called a place table. So this is just a word that I made up, but what a place table does is it just lists how many votes of each preference each candidate received in an election. All right, so hopefully that's intuitive enough. I will do this for vanilla first, and then I'll pause for you to fill out the rest of the place table. So the exercise here is to use the preference schedule above to fill out the place table for the ice cream election. So this ice cream flavor, we have vanilla right here. And so we want to figure out, well, how many first place votes did vanilla get? Well, I go up to my preference schedule right here, and I see that, okay, 20 people and 18 people, those were the two groups of people who voted vanilla first. And so that means that vanilla ended up getting 38 first place votes. Then I want to go into the second choice row right here, and I have 24 people who voted at second choice, plus 11 people who voted at second choice. So I believe that's going to give me a total of 35 second place votes. And then you just go to the third row. So it's nice and relaxing once we get into a groove. 18 people voted vanilla third place here, and then 9 people voted vanilla third place right here. And so that gives us a total of 27 right there. So why don't we pause for a second and you fill out the place table for mint chocolate chip and salted caramel. Okay, back at it. So hopefully you paused. Hopefully that didn't take too long. And I ended up with the following answers right here. Mint chocolate chip got 42, first place votes 27, second place votes 31, third place votes, and we just calculated it the same way we did for vanilla, just counting along each of the rows. Similarly, I got 20, 38, and 42 for the number of first, second, and third place votes for salted caramel. All right, so if we can calculate the preference schedule and the place table, we'll be able to figure out our winners of election using all of the data presented. So yes, the key idea here, a preference schedule and place table, it tells us everything that we need to know. All right, so let's actually get into talking about some methods of election. So the first method that we're going to talk about is the plurality method. So the plurality method is the simplest form of election, and the winner of the plurality method is decided by who has earned the greatest number of first place votes. That's it. The complete ranking or the full ranking is decided by sorting the candidates in descending order based on first place votes. So our ordering is just going to be ranked on who got the most first place votes. All right. So what we can do right here, you can pause for a moment, and then I'd like you to consider the following 3 questions. Which ice cream wins under the plurality method? What is the full ranking under the plurality method? And then invite as an opinion if you think this result is fair. So why don't we pause for a second? You might have to scroll back up into a previous part of the video to look at the preference table, but I'll pause for a minute while you think about these 3 questions. All right, so hopefully you are all able to figure this one out. The plurality method is pretty familiar. So for which ice cream wins under the plurality method? Well, this is very easy. It's mint chocolate chip. And the way that I calculated that was I just went to my place table right here. I looked at who got the most number of first place votes, mint chocolate chip with 42. So under the plurality method of an election, they would be listed as a winner. Now, to get the full ranking of the candidates, also known as the complete ranking of the candidates, I'll use the abbreviations this time. The answer is first place goes to M, second place goes to V, and third place goes to C. Again, all I did was look at mint chocolate chip was first, the next most went to vanilla with 38, and then salted caramel got 20. So that's how we can give, our first place, second place, and third place under the as the outcome. So that would be our complete ranking of the candidates. And then I hope you thought for a second about if this election is fair. And we'll talk about fairness a little bit more in future videos, but this is an opinion. There's not going to be a correct answer necessarily. And to me, this seems fine. I mean, mint chocolate chip was the most popular, so it's the winner. But one thing that might be frustrating about the plurality method with more than 2 candidates is that a majority was not reached by any particular ice cream. So maybe it feels wrong to call the winner something that didn't achieve the majority, because it turns out that, well, the majority of people actually don't think it's the best ice cream. So that's kind of one of the weaknesses of the plurality method. And of course, the method we used above, this always works. We can just convert the preference schedule into a place table, and then we can just count the first place votes. And the first place votes tell us the complete ranking of an election. All right. One thing that I've intentionally avoided is ties. So you might be asking, wait, Jeff, there could have very easily been a tie in an election. So what do we do in this class with ties? So the first thing is I'm going to try to avoid them as much as possible. You can explore them in homework or in other exercises, but really each method of election will need its own tiebreaker that we as human beings deem appropriate. There's not going to be like a perfect mathematical tiebreaker. So I think they're best when they're situation specific. So maybe in some cases, like if we're debating what pizza we get, maybe at some point we just flip a coin. Like it's probably not worth having a whole election over it if we use the plurality method to debate what pizza that we want. But in Congress, we decide that the vice president breaks ties. That seems a lot more reasonable than, when we have a 50 versus 50 vote in the Senate decided by a coin flip. So maybe some other good tiebreakers for the plurality method, that would be who has the most second place votes. Maybe we can somehow incorporate the second place votes into the tiebreaker for the plurality method. Or maybe we can try to filter out, well, which candidate was the least unpopular. So we could say, well, the tiebreaker, if there is a tiebreaker, would be who has the least amount of last place votes. So that, well, we just take the candidate who is, I guess, hated or least preferred the least in that sort of situation. So tiebreakers, we'll just have to kind of come up with them as they go on. Sometimes they're random. Sometimes we can just use the preference schedule to make a tiebreaker. All right, so that's what we have to say about the plurality method. So the next method that I would like to talk about before concluding this video is the Borda count method. So suppose that we're studying an election that has n many candidates. Maybe n is equal to 3, maybe n is equal to 4. It's just a variable. Here's how the Borda count method is going to work in such an election. So the first step is that we are going to use the preference schedule for that election to make a place table for an election. I think the Borda count is most easily calculated when you use the place table. The next step in a Borda count election, and it's a little bit confusing, so let's just talk about it slowly. What we'll do is we'll use the place table to calculate the total points, the total Borda count points for each candidate. Now, points are calculated by multiplying a candidate's first place votes by the number n. We multiply the number of second place votes by n minus 1, and we keep on going. So with 3 candidates, for example, we'd multiply each candidate's first place votes by 3, second place votes by 2, and third place votes by 1. If we had 4 candidates, we'd multiply the first place votes by 4, the second place votes by 3, the third place votes by 2, and then the last place votes by 1. So we sort of So the Borda count method is going to weight the first place votes higher than the last place votes. So we kind of want to reward all of those. We'd like to reward, how do I say this best? We want to give the most weight to first place votes and the least amount of weight to last place votes. So once we do that procedure, which is just easiest to learn by an example, we just sort the candidates by their total points. We sum up each candidate. So each candidate will get a total amount of points. And then we will sort the candidates by their total points in decreasing order. And then our conclusion is that step 3 is going to give the complete ranking of the candidates. So the winner of a Borda count election is going to be the person or thing with the most amount of points. And then we will sort the rest of the candidates to get the complete ranking in descending order from that. Oops, sorry about that. All right. So if you like formulas in an election with n candidates, the total number of points earned by a candidate in the Borda count method is given by this, right? We multiply the number of first place votes by n, and then we let n decrease by 1 as we go down in the votes. So n times the number of first place votes, n minus 1 times the number of second place votes, 1 times the number of nth place votes. We just keep on going. Like I said, it'll be a little more clear when we study an example. And let's actually go ahead and do that, study one of these examples. So in this activity, we'll use a place table to calculate the winner and full ranking of an election using the Borda count method. Again, you may have to pause and then rewind and look at the place table to do this. So feel free to do that. So the first question is calculate the Borda points for each ice cream and find the winner. And I want you all to investigate if it's the same as the plurality method. And then what I'd like you all to do is find the full ranking of the ice cream under the Borda count method and ask, is it the same as the plurality method? And then we can think about if we think this result is fair. Do we think that the Borda count method is better for this selection, or if the plurality method is more well suited? So why don't you consider all of these questions, pause the video, maybe go up to the place table, and then we will keep on going and go over the results. Okay, so you've unpaused the video, or you just want to see what the results were. So here is what I came up with for calculating the Borda points of each ice cream. So for vanilla got 38 first place votes. There's 3 ice creams in the selection, so we multiply the first place votes by 3. So we do 3 times 38 plus 2 times 35, the number of second place votes, plus 1 times 27. I plug that into a calculator. I got 211. Mint chocolate chip got 3 first place votes, so we multiply that by 42. They got 2 second place. They got 27 second place votes, so we multiply 27 times 2, and 31 third place votes. So we multiply. So we just multiply 1 times 31, and we get 211. And then we follow this procedure again. 3 times first place votes, plus 2 times second place votes, plus 1 times third place votes. For salted caramel, we end up seeing that salted caramel has 178 points using the Borda count method. What do we see? There's a tie. So that's very exciting. I didn't even have to cook the books to create a tie right there. So we're going to have to create a tiebreaker to analyze this question. And I think a good tiebreaker is, let's use the fewest amount of last place votes as a tiebreaker. So if we scroll up to our place table for the election, we see that, well, it's a tie between vanilla and mint chocolate chip, but mint chocolate chip had the most third place votes. So it was the most unpreferred. It's tough to get these double negatives correct right here. So mint chocolate chip has more last place votes. So if we use the fewest last place votes as the tiebreaker, vanilla would be the winner. And then the tie, mint, would be second place. And then salted caramel had less place points than all of them. So it would finish in third place right there. So that's a fun example of a tie showing up in real life in a real classroom. And then do we think the Borda count method is fair? You know, it's the plurality method. This is an opinion question. I don't want to be the I don't want to be the final authority of this. One thing that I like in an election like this is that the Borda count, it sort of incorporates the fact that some candidates are not preferred. It sort of gives us the average. And in an election like this with multiple things, when it's about something like ice cream, I think it is good to use something like the Borda count method because it incorporates everyone's full preferences, not just their first place votes. So if an ice cream was particularly unpopular, that would have been somehow included in the Borda count method. All right, so what we'll just do for the rest of this video is I'll just do a couple pauses and a couple reveals as we just review what we learned about the plurality method and the Borda count method. So The table below, it just shows the preference schedule for an election with 4 candidates. We'll just call the candidates A, B, C, and D. Keep it very abstract for now. We have the following preference table. Looks like 27 people had this preference, 8 people had this preference, yada, yada. All right, so the questions that I would like you to all answer is how many voters are in this election? What is needed to get a majority? And if you could calculate the place table for this election. So I want you pause. I want you pause. You can go through this and then you can unpause once you're ready to move on. All right, so now that we've unpaused, here's what we can do. So if we want to find the number of voters, the nice thing about a preference schedule is that we can just add up all the voters in this top row right here. So if we do 27 plus 15 plus 11 plus 9 plus 8 plus 1, we get 71 total people. To calculate the majority, we just divide 71 by 2 and we get 35.5. 71 is an odd number, so we round up. And so that means that the majority is 36. It would require 36 votes to achieve a majority. And then right here, I don't want to go through it in detail, but you can pause the video for a second here and just make sure that you got the correct place table for this election. One thing you may have noticed is that like candidate C, for example, got no second place votes. So you just put a 0 in there. Sometimes things work out that way. So this is our place table for an election. That will be very helpful as we calculate with the Borda count method. All right, so let's scroll down and answer some other questions about this election. So what I would like you to do is think about what's the full ranking of the candidates using the plurality method and what's the full ranking of the candidates using the Borda count method. And then I want you to see if you can compare the results. Are the results the same or are the resulting winners different? And then of course, just continue with the theme. Think about the fairness. Think about, what's the difference between the plurality method and the Borda count method? So you can just pause the video here. You might have to scroll up just to get all the data, but you want to find the full ranking using plurality, full ranking using Borda count, and then compare those results right there. So I want you to pause and work on that, and then I will start again soon. All right, so going back, we want to find the full ranking of the candidates using the plurality method. And again, the plurality method is not too hard. What do we get for the results right here? The full ranking is, we just count who got the most first place votes and then list them in descending order. So that means that C got the most first place votes, B got the second most, A got the third most, and D got the least amount of first place votes. So that means that the full ranking of the candidates using the plurality method is C, B, A, and D. Hopefully you had some time to calculate the number of points that each candidate got with the Borda count method. And so I will reveal those results right here. So because we have 4 candidates in this election, we are going to multiply the first place votes by 4, multiply the second place votes by 3, multiply the third place votes by 2, and multiply the fourth place votes by 1. And so if we do this for A, B, C, and D, what we will see is that A got 163 Borda count points, B got 197 points, C got 160, and D got 190. So that means the complete ranking of the candidates in this case are going to be B, D, A, and then C with the least amount of Borda count points. And so we will see right away that the full rankings are not the same whatsoever. In fact, a very extreme thing has happened. C got first place with plurality, but C got last place with the Borda count method. So if we wanted to maybe think a little bit about fairness, I mean, there's not a right answer or a wrong answer, but one thing we can observe is that the plurality method winner C was extraordinarily unpopular amongst the rest of the candidates. We can see this in the preference schedule right here. So if we go up to the preference schedule, we see 27 people, so not a majority, but a large amount of people preferred candidate C. But if we look at all of the other voters, a majority of them, in fact, they had C as 4th place, 8 people had C as 3rd place, but that's the nicest thing that the non-C in 1st place people had. So again, kind of one nice thing about the Borda count method is that it sort of averages these things out. When you have a very polarizing candidate, it does give hope that maybe, even though that's the most popular candidate with the plurality candidate, maybe somehow after you average things out using the Borda count method, a different winner who maybe people have less polarizing views on will emerge. All right, so I hope this video was helpful, and stay tuned for the next video where we'll talk about two new forms of elections. Thanks.